This is Mr. Holsey of H Squared's Officially Understood Science, doing a special request tutorial on advanced Bohr models. So we're going to be talking about how to create Bohr models for elements that are over an atomic number of 20, so past calcium on the periodic table of elements. And this includes those tricky transition metals that we've been talking about. And so the first thing you need to understand is that once you get past 20, the orbitals and shells start to have different shapes. So you can see that right here. So there are four types of orbitals that we're going to be talking about. The s orbital, which is right there. That means S means sphere. So those are the smaller orbitals, and they can hold 2 electrons. Then you have the p orbital, which has a very kind of like bow tie shape. Those can hold 6. The d orbital, which kind of looks like a flower, that can hold 10. And the f orbital, which just looks like a completely jumbled mess, but it can hold up to 14. And so when we are using this, we're going to be taking a look at this diagram out to the left-hand side of the screen. And how this diagram works is actually quite interesting because it doesn't go in a straight horizontal line. Instead, it works on a diagonal, like this. Sorry. And so this is how you would follow along with this model. So you move in a diagonal across the diagram. And that's going to tell you how you're going to fill out your valence electrons. So we talked about 2, 8, 8, 18, and 2, 8, 18, 32. And I told you the transition metals were the reasons why we have the 2, 8, 18, 32. So let's take a look at this really quick. So in the first shell, this 1 means the first shell, we have 1s. So that means we have one s orbital in the first shell, so 1s. So there's 2. Then in the second orbital, we have an s orbital and a p orbital. So 2 here, 6 for the p, 8. We can keep following this pattern. Here's our third shell, 2, 6, and then we have a d orbital, which is 10, 18. Fourth shell, S, P, D, F, 32. And so you can see how we get this pattern, this increasing pattern. And so we're going to go ahead and do an element to kind of show you how this all works. Now I'm going to still use some of the same tricks that I've been doing to keep the number of my elements accounted for, or number of my electrons accounted for. So we're going to do scandium. So you can see the periodic tile for scandium right there in the corner. And so the first step when creating a Bohr model is to do 8-man. So I'm going to do 8-man right here. So my atomic number for scandium is 21, which means my protons are equal to 21 and my electrons are equal to 21. The mass of scandium, when rounded, is 45. My atomic number again, 21. We make that into a little subtraction problem. So that is going to be 24 neutrons. So now we have an idea of what it's going to look like. So I'm going to do P, my protons, 21, E, 21, N, my neutrons, 24. And so I can go ahead and erase all this. I don't need it anymore. So on the periodic table, you'll see that scandium is in the fourth period on the periodic table. So I'm going to go ahead and make my nucleus and my 4 shells. Alright, so remember in a Bohr model in the nucleus, we're going to place our protons and our neutrons. Protons are 21 and neutrons are 24. Alright, so now I'm going to go ahead and start off down here, and in the bottom I'm going to write 21 because that's my electrons I'm going to start with. So we're going to go at a diagonal angle. So we're going to do 1s. So that means in my first shell, I'm going to have 2 electrons. And as you go through this, it's a good idea in your mind, I'm going to draw this out for just a second, to use that little, what I told you guys about making a little grid or a target and moving around, because especially with these bigger atoms, it's going to be quite difficult to keep keep track of all of them if you don't do this. So it's very important that you try and keep those accounted for. So we have our first 2 in the first shell. I'm going to mark out 21 because I don't have 21 anymore. I have 19 electrons remaining. And I'm going to go at an angle and do 2s. So second shell, I have 1, 2. So once again, s means 2. Now we're hitting up our first p orbital. So I'm going to go through, there's 2p. So p, once again, is 6. So 1, 2, 3, 4, 5, 6. Okay, so now keeping going with our diagonal, now we have 3s. Oops. So we just got rid of another 8 in that second shell. So we got to keep hold of our track of our electrons. So there's 11 left. And so right here we got 1, 2. So now we have 9 left. So we're going now to go to 3p. P meaning 6. 4, 5, 6. I have 3 left. Now I'm going to 4s. That's 2 more, but this time in the fourth shell. 1. I'm going to put it at the bottom. 2. And I have 1 electron left. Now this is where things get a little bit confusing, because instead of continuing on the fourth shell, what I'm going to do is I'm going to be going back to the third shell, because that's the next one in the diagonal. So I'm going back to 3D. And essentially, remember, D means I can add 10. Okay, I can add up to 10 more valence electrons in that orbital. And so I'm going to be going back into the third orbital. And this is how a lot of transition metals are. And so I'm going to place that one right there. And I'm going to use red to kind of highlight it. And now I'm at 0 electrons. So I only have 2 valence electrons. So if I were drawing a Lewis dot for this, I would have 1, 2 valence electrons. And so, but on the inner shell, the third shell, I have more than 8. So that's where we get that whole 2, 8, 18. And if I continued going down this, I would see that I'm adding more and more to the inner shells as I go. So you can use this method for any of the elements for any element on the periodic table. And just so you guys can see, this is in fact the Bohr model for scandium. And it can be used for any of them. It can be used for any of them. And what's really interesting about that process I just showed you is we can actually overlay those orbitals on the periodic table. And so you can see hydrogen and helium will only be in 1s because they only have one shell. The second period of the periodic table, the second row, has 2s and 2p, which 8 electrons, 2 electrons, 3s and 3p for the third. So once again, 8 electrons. But then you notice on the fourth shell, we have 4s, 4p over on the left and right hand side, but in the middle with the transition metals, we have 3d, where we're adding more to the inner actual electron configuration. And so you can see that pattern as you look through this. Now we'll get to F shells down here in the rare earth metals. Well, this has been a tutorial on advanced Bohr models. Once again, this is Mr. Holsey with Sufficiently Understood Science. Remember to hit the like, share, and subscribe buttons, and hit that little bell notification to know when we upload a new tutorial. Alright, see you later.